Example 2, we're going to find y prime if x cubed plus y cubed equals 6xy, and then find the tangent to the folium of Descartes' x cubed plus y cubed equals 6xy at the point 3, 3. And then at what point in the first quadrant is the tangent line horizontal? So the first thing that we're going to do is we're going to look at part A. Okay, so when we look at part A, okay, we're going to be differentiating both sides with respect to x, regarding y as a function of x, and then using a chain rule on the term y cubed and the product rule on the term 6xy. So that means if we're taking a derivative of both sides, so if we're looking at the function, okay, x cubed plus y cubed equals 6xy. So now in step 2, we are going to differentiate both sides with respect to x, and again regarding y as a function of x. And then we're going to be using a chain rule on the y cubed term and the 6xy term. So when we take the derivative of x cubed, that means we get 3x squared. Plus, we're going to use the chain rule on the term y cubed. So we're going to take the derivative of y cubed, which is 3y squared, and that's going to be multiplied by y prime, which is equal to, now we're going to take the derivative of 6xy, and we're going to use the product rule on that term. So the first thing that we need to do is we're going to take the derivative with respect to y, so we end up getting 6xy prime, plus when we take the derivative with respect to x, we're going to get 6y. Okay, now if we want to simplify this a little bit easier, we can divide all these terms by 3 on both sides of the equation. So what we end up getting is x squared plus y squared times y prime, which is equal to 2xy prime plus 2y. Okay, now again, going back to part A, our goal is to solve for y prime. So we have a y prime in this term on the left side and a y prime in this term. We're going to combine all the y prime terms on the left side and everything else on the other side. So on the left side, we have the following. We have y squared times y prime minus 2xy prime. And then on the right side, we have 2y minus x squared. So now on the left side of the equation, our goal is to solve for y prime. So if we factor out y prime, then what's left is y squared minus 2x, and that's equal to 2y minus x squared. And now if we want to solve for y prime, we're going to divide both sides by y squared minus 2x. So y prime, or the derivative, is going to be 2y minus x squared divided by y squared minus 2x. So therefore, there is the derivative. Okay, now for part B, the question is asking us to find the tangent to the folium of Descartes' x cubed plus y cubed equals 6xy at the point 3, 3. So let's look at this on Desmos first. We're going to put in the function x cubed, okay, plus y cubed, which is equal to 6xy. So there is our graph. And then we want to find the line that's tangent at the point 3, 3. So if we take a look at the point 3, 3, we can see that it's located right there. So we should have a line that's tangent there. Okay, so that means in the ordered pair 3, 3, we know what the values of x and y is. So for part B, okay, if we're looking at the ordered pair 3, 3, then that tells us that x is equal to 3, and that tells us that y is equal to 3. And what we're going to do is we're going to plug in those values into the derivative in part A so we can figure out what that slope is going to be. So we're going to plug in x to be 3, and we're going to plug in y to be 3 as well. So let's plug it into our derivative. So we have 2 times 3 minus 3 squared all over 3 squared minus 2 times 3. In the numerator we get 6 minus 9, which is negative 3. In the denominator we get 9 minus 6, which is positive 3. So therefore we get a slope of negative 1. Okay, so what we want to do now is then use the point slope form. Point slope form, y minus y1 equals m times x minus x1. So we have y minus 3 equals negative 1 times x minus 3. So there is the point slope form. If we want to solve a little bit further, we get y minus 3, which is equal to negative x plus 3. And so therefore y is going to equal negative x plus 6. So therefore that represents the line that is tangent to that. So let's go ahead and put that line into Desmos. So we have the line, okay, we'll go ahead and label that. Okay, so we have negative x plus 6. So now we can see that that line is tangent at that particular point. So let's go ahead and copy that. So therefore, there is our graph. Okay? So now in part C, it says at what point in the first quadrant is the tangent line horizontal? Okay? So what that means is that we want to find out, okay, the tangent line. So the tangent line is horizontal when or if y prime is equal to 0. Okay, so we're going to use the expression from part A, okay, and we see that y prime is equal to 0 when? So y prime is going to equal 0 when what? 2y minus x squared is equal to 0. So if you take a look at part A, right, y prime is going to equal 0 when the numerator, right, the numerator 2y minus x squared is going to equal 0. Okay, and provided by the fact that y squared minus 2x does not equal 0. So let's solve for y here. So in part 3, we're going to solve for y. So we have 2y minus x squared, which is equal to 0. So we have 2y, which is equal to x squared. And divide both sides by 2, then y is going to equal 1/2 x squared. Okay, so now that we know what y is, okay, now we're going to then use our curve. So that means that our curve that we started out with was x cubed plus y cubed equals 6xy. And so what we're going to do now is we're going to replace, okay, this y, which is equal to 1/2 x squared, for those y's. So in step 5, we have x cubed plus, now what are we plugging in for y? Well, it's going to be 1/2 x squared, and then we're going to cube that. and that's going to equal 6x times 1/2 x squared. Okay, so let's go ahead and simplify this a little further. So we have x cubed plus this becomes 1/8 x to the 6th, which is equal to 6 times 1/2 is 3, and that's 3x cubed. Okay, so now let's subtract x cubed to both sides. So we have 1/8 x to the 6th, which is equal to 2x cubed. And then if we multiply both sides by 8, then x to the 6th is going to equal 16x cubed. Okay, so now let's set this equal to 0. So we have x to the 6th minus 16x cubed, and that's equal to 0. So what does that mean? That means if we factor out an x cubed, we have x cubed times x cubed minus 16, and that's equal to 0. So that means we have x cubed is equal to 0, or we have x cubed minus 16 is equal to 0. Now over here, x cubed equals 0 tells us that x is equal to 0. But since we're looking at the first quadrant, okay, we can't say that x does not equal 0. So x does not equal 0 in the first quadrant. So what we're going to do is we're going to look at x cubed and set that equal to 16. Okay? So if we take the cube root of both sides, which means that if we raise this x to the cube root to the 1/3, well, that equals 16 to the 1/3. And so now what we end up getting is x, which is the cube root of 16. Well, remember that 16 is the same thing as 2 to the 4th power. So if we rewrite this now as an fractional exponent, well, this is the same thing as 2 to the 4/3. Okay, so therefore that is the value of x. Okay, we want to find out what is the value of y. Well, we know that y, the equation for y, was equal to 1/2 x squared. So we're going to plug in x into there to find out what y is. So y is going to equal 1/2 times 2 to the 4/3 raised to the 2nd power. Okay. So what does that equal? Well, that's going to be y, which is going to equal 1/2 times 2 to the 8/3. And remember that if you have division, if this is 2 to the 8/3, and you're dividing it by 2, that's the same thing as 3/3 for the exponent. If you subtract exponents, then y is going to equal 2 to the 5/3. So again, the question is asking us what? It's asking us, okay, at what point in the first quadrant is the tangent line horizontal? Okay, so let's take a look at this point. Well, this is an ordered pair of 2 to the 4/3 and 2 to the 5/3. Okay, now if you wanted to calculate this on your calculator and find an approximation, well, then you're going to get the following. You're going to get 2.5198 for the x, and then 3.1748 Okay, so let's just take a look at that on our graph. Okay, let's plot that point. Is that going to be in the first quadrant? So we'll go ahead and plot that point. So we have 2 to the exponent of 4 divided by 3, comma, and then we have 2 to the exponent of 5 divided by 3. Okay, so let's take a look at that graph. So there is that graph. There's the point on there. And so that is going to represent, again, the point where you're going to have a horizontal tangent. And we can see that it's estimated here.